Thank you, Dridge. Yeah, so my name is Tom Pittenger. I'm Magic Grub on GitHub, and here is Sid. He says hi. Yeah, so we're talking about adding networking support, native networking, right into the ArcherPilot stack. But first, I figured since GPT exists, we should at least try to have it write something for us. So I actually tried this. This is just a quick tangent. Write a presentation adding networking to LWIP, and then that actually was surprisingly good. But then, of course, you have to add in stereotypical slang. So we can totally do that. It's actually hilarious. We won't do it right now. I'm just kidding. So intro to LWIP, which is the lightweight IP stack. That is the IP stack that we're using on ArcherPilot. It's just designed for kind of embedded systems, low memory footprint, that kind of stuff. Talk about how we enter it into the autopilots, some MAC address stuff, and then stuff we've been doing with it. So, and of course, a demo. I got some hardware here. So the features of LWIP by itself is it's just optimized for small flash and small RAM footprint, with everything included in ArcherPilot, with all the features that we're basically going to use and all the parameters and configuration and all that. It takes about 80K of flash. So not really that much considering it's a fairly significant feature. I mean, it's a very significant feature. LWIP is the IP stack of choice that actually comes embedded with ChibIOS. I've used LWIP in other applications before my life at ArcherPilot, but it's been around for a while, and it's nice. It actually came with ChibIOS. It's kind of wrapped in it or embedded in it. It implements all the usual suspects for IP protocols: ARP, IPv4, 6, UDP, TCP, amongst others. The ones I have in bold here are the ones that we've implemented that are exposed, that are actually actively being used. But the hooks are there to do all kinds of other protocols. They're just defined out for the moment. But yeah, so we have a web server. It'll handle DNS requests. SNTP is for the time protocol. So if you have internet access or some sort of local time network, you actually can the aircraft would know what time it is without a GPS. All that sort of stuff. The general interface to ArcherPilot is going to be through the AP networking library, and it's fairly straightforward to set up. You just set your Boolean for enabled, and most of these require a reboot to take effect as well. You can set your IP address. Right now, there's IP 0, IP 1, IP 2, IP 3, and you just set those numbers to be what your IP is. And that's if you want to do a static IP address. There's net DHCP to turn that on, and then it'll boot up with IP of 0, and then it'll just be asking the network for a DHCP server to give it an IP. And the net mask is not, you don't say 255.255 or whatever, you actually just say how many bits you want. So for the example here is 24 bits, or 24, and that'd be equivalent to 255.255.255.0. MAC address is, we have some defaults in there, but it's just 6 parameters. You can put in whatever you want, essentially. But there are some mechanisms we'll talk about later that make it more unique for as people start using this. And then net options, which is a bunch of bits that you can turn on larger features, such as TFTP, net BIOS, time servers. You can do a mail server. There's all kinds of other stuff we can start doing on there. And a lot of these are all defined in a way that you can define them in your hardware-defined file for your build target. So you can say that this device will boot up and it'll have net BIOS of this name or something. And then there's going to be a net and then a number and type for each add-on libraries. So right now we have just 2 libraries that are kind of like embedded C code files, typical drivers in the ArcherPilot library that are running within the scope of this library, that you can do whatever custom stuff you want in the C++ world, and you'll just get updated 1 kilohertz. And the two that we implemented is a speed test, and another one is a latency test. But you can just build from those examples to just build whatever send receive sort of UDP, TCP, whatever examples you want. For MAC addresses, LWIP comes with this kind of defined default one. It's sort of an invalid one. It's kind of like having your IP address on a computer where it says like 169.1 something. It's one of those like non-routable-ish, but it works. It's just expected to have lots of people around the planet have it. It's designed to be replaced with more unique numbers. So it's kind of a placeholder. On QPilot, they actually own a 24-bit block of MAC addresses. So they have A8, B0, 28, and then the last 3 bytes on either with the QPilot hardware or not. I built a mechanism into it so that it takes the UDID of your hardware and replaces it as default. At least you can still replace it with whatever value you want, but the default becomes whatever the UDID is of your hardware. So you should be getting more random or more unique devices as there's thousands and millions of these come online. And performance. So a little bit of a disclaimer here. This is, all this is an initial, we got this working. There's lots of things in RTOPilot that don't expect tens of megabytes of throughput and stuff. So there's lots of bottlenecks that exist that we know about, that we just need to spend some more time in to make sure we don't break anything else and that. So there's some of them that we know about, and I'm sure as we go along, we can just, it's one of those things we can optimize forever on this sort of thing. So right now, I think it's just kind of considered preliminary. So it's still pretty good. It's a lot better than Serial, but it's going to get better. So first, speed test. The idea is just fill a packet with 1472 bytes, and they can be user defined, or if you in the parameters of this library. So if you say like net one type one or whatever, when you do that, it'll pull up some more parameters, and there's like what kind of content you want or whatever. You can send just all zeros or all fives, or if you say -1, it'll send a string of like, welcome to RTOPilot and whatever. That's just what it's spamming out the port as fast as it can. So that's what this is. It's just send a string over and over of 20 characters or whatever, saying hello world kind of thing, and to a port that you choose. And it works at like 87 megabits. Like 80, it kind of varies a little bit depending on what's going on, but it's 85, 84, it's 87, pretty fast. So this is at the C level in RTOPilot. That we're talking down to LWIP, talking down to Chibios, and that's just raw ability for us to push data out. So we're basically limited to the 10100 link on the hardware we're using. But in theory, if this was on Raspberry Pis or some x86 systems, you would get gigabit kind of speeds too. So there's nothing in the autopilot itself that's inhibiting the data packets from going out. It's more about when we start interacting with data that is using it, like when we do like Mavlink and the SD cards and all that, it's going through other mechanisms that aren't expecting ginormous amounts of data. So latency test. So I've built this in. We didn't have time to really test it thoroughly with multiple hardwares, but I have this little library that we can start testing with, where sort of a worst case latency test where you have on a local LAN with a switch, a couple hardware connect together, where you turn on the feature and they would say, they send out one 32-bit number of the number 1, and then if anyone receives that, they'll take it and then increment it and send that out. And then whoever receives that would increment it and send it out. So you have 2 guys going back and forth, and just how fast can the number grow, right? So that's the kind of a ping-pongy sort of thing of just latency of here's 1 byte. You got a whole bunch of overhead for IP routing and all that, but just with 1 int of a payload, how fast can we just slam that back and forth between the 2 guys? And so we don't have the results for that. We haven't done the test, but we're guessing it's somewhere in the 200 to 400 sort of range. But results are TBD for that. So also TFT. Oh, question?
We have a few questions on YouTube if you can answer.
Sure.
And also echo them out on the mic so that others know what you're talking
Yep.
about.
Your questions.
Yeah. So, can the playman asks if SSH and SFTP is supported?
SSH and what?
SFTP.
SFTP. So I was just about to get to the TFTP. Right now, we don't have SSH capabilities as far as it wasn't a default thing that came with LWIP. It's still something that we could implement. Nothing stopping us from doing that, but it's not currently in there. As far as and same thing with
FTP.
Yes, FTP.
You also will have to probably include SSL libraries and encryption as well. So that's
anything encryption related. There is support for HTTPS, but otherwise, there's encryption right now is absent for the most part. There's hooks for it. We just haven't implemented that stuff quite yet. There is the one that does come with it is TFTP, and that's trivial FTP, which is a much more primitive, lightweight, low memory implementation of FTP. It's not secure at all. It's just designed for use within networks, within local networks and stuff like that. It doesn't handle packet fragmentations and stuff like that very well. But it's machine-to-machine talk that are near each other. And with that, we were able to kind of transfer files or transfer data from a computer to the SD card from the computer to the device. It would receive it at about 1.4 megabits, and then we could read from it at 2.2. So we need to find out what those limitations are. I know a lot of it is TFTP itself is a limitation. There's no windowing or anything. It sends a byte, waits for an ACK back before it sends another one, and stuff like that. There's no queuing of that sort of stuff. So it's designed to be very low memory and stuff. So it would be nice to see where this goes when we put it in a more TCP oriented windowing proper FTP implementation. So this will definitely do a times 10 or so. I'm guessing. We'll see how that goes.
And the other question is, how does this interface? Like, what's the port that you're going to use?
So we have a hardware. I got a hardware slide here. Think about what the hardware options are in a minute. Anything else?
No.
All right. So maybe how would you talk about this one?
Yeah, sure.
Yeah.
I mean, so we are adding serial extensions basically in ArduPilot. So this has been, something that I've been working on from the DroneCan side, and I had, pictured that this is the same thing we'll do with IP as well, where you have currently in ArduPilot serial 0 to 9, basically 10 serial ports, which, connect to a physical serial UART device. So we want to be able to have sort of more pseudo serial ports, sort of, be able to select what physical type of that serial is going to be. So in this particular example is like we are going to have something from A to F for now, and maybe even more in the future, where you can basically select what type of physical type you want to send that serial over, and you will basically set the physical type, and it will just load the parameters that are relevant for particular physical type. So if it is IP, it will, what's the destination IP, what's the port, and you set that, and it will just stream your UDP package to that particular location. So that's sort of the architecture that we are going for. And, of course, this will just appear as HAL.serial in the, ArduPilot space, and you'll be just able to use any sort of protocols through serial manager that you are able to, but on different physical types. So this is just ease of configuration, sort of ability that this serial extension will give users in the near future. So yeah, I mean, I'm going to talk a bit more about it in DroneCan space as well. So yeah, you can continue.
Yeah. So in short, it basically allows a virtual serial port that you can connect any protocol to IP or to CAN. So that way, over your IP link, which you can configure it as TCP client server, UDP client server kind of things. Then you can become it's just talking to it as if it's a GPS, or if it's a rangefinder, or if it's some Mavlink. Any sort of anything that's in the serial manager protocols. It's just so without having a physical serial port, you can just be talking as if that's the port over the IP. So that allows us to have a dozen Mavlink ports or whatever, and you don't need, has nothing to do with serial. And then do all kinds of your custom protocols. So, yes. So, and how this interacts with scripting. So we have scripting basically has hooks in there now for us on our branch that is just raw TCP and UDP packets. So you can do whatever you want. A server client on either of them, and it'll just wait for messages, and all the hooks that we use down in C, they're all brought up to the server side. We only have one demo right now. We've done a few things, but as far as what we plan to initially push into to upstream master is a web server. So we have an example of the web server where it's actually hosting content and all. So on the web page, you actually have the ability to see some live data that's interacting with like the time or the battery voltages or something, and actually display it on a generated HTML page. So sort of on here, the sky's the limit. It's just you have now full reign to talk IP. What I started testing on was I was working. I'm with Kraus Hamdani Aerospace, and we built some hardware for the upcoming Cube Red. So on the Cube Red, that has 2 sockets on the bottom, if you notice, and that allows us to be we can be backwards compatible with, if you don't populate that, we just have the Cube Orange in there. And then I had a little periph I was making that where the sockets are. Am I not showing up there? No, yeah. I had a little periph that was in there that we were actually running the IP stack on a periph. So using AP periph, we're basically able to do everything that the aircraft can do. And it just gives you a much smaller, lightweight footprint to do everything that periph can already do, but do it with IP, right? So I was using this to do a basic UART to UDP converter. So on this, we were able to do some development, testing with this. Great relationship we have with QPilot. They're a great help on the Sid's working on kind of the lower level stuff, and I'm looking on a little higher level. So great teamwork on there. Some major to-dos. So things that we already know we want to do, but we're of course looking for whatever else you guys can think of. But IP-based bootloaders. So that's going to be a one we'll want. You can already do Mav FTP, so you can fetch log downloads, and now Mavlink is just better, faster, anyways. So you already have an instant better log downloads right now, but it's only like let's say like 2.5 megabits or so. We want to try and get that up times 10 at least, something. So implementing a way to really transfer massive files back and forth to your SD card and handle all those giant log files. Tons of room for improvement on optimizing stuff. So for latency, throughput, all that kind of stuff. There's lots of room for improvement we can do on there. We want to get some more HTTP examples. So get some more web pages in there. And I'll show you one in a minute. But it's good to show like I actually have images embedded in the firmware. So there's all kinds of neat tricks we can do with this. So get better examples of that so people can start building their own thing. But even better is having possibly a GCS or a lightweight GCS right in as a web page. So you just access the web page it's hosted on the device, and then you can maybe see plots, check your parameters, fiddle with things. The sky's the limit for modifying whatever you want at that point. You don't have a standalone computer. You can just talk directly to the aircraft. We'll be able to have much better interfacing with payloads because a lot of payloads and cameras especially, they're all IP based for getting lots of data off of them. Now it gives us the ability to just talk directly to them and control them and whatnot. So that gives us a new avenue to really open up better support and encryption. So that comes back to the question earlier about SFTP and SSH and other things. So that's on the roadmap. We'll be doing that, but also just encrypting all your data and all that kind of stuff. The chip that's being used on the Cube Red, which is what I've been developing on, it's based on a CPU that has hardware acceleration on encryption. So this will actually work really well with that and not really take up any headroom for or it won't hold anything back. It's harder accelerated. And pull request welcome, of course. So demo. Let's show you a little bit of a demo here. I have a cube on here, and then on my computer I have a USB-C going to with Ethernet, and and with USB to power the board. But I'm not doing anything with USB. I'm just using that for power.
We got a demo. I think you missed something right at the beginning. Why Ethernet? What is it useful for? What device is going to connect to? How are people going to use Ethernet on real digs?
Sure. Yeah. The question is the big why? Why do this at all? What does it give us? And so a lot of new radios are all expecting higher bandwidth, and a lot of those are all IP based. It gives you out of the box better like aircraft to aircraft comms, and lots of devices are also Ethernet. So it allows you to have to get away from the more ancient serial UART interface. You can talk to multiple devices now, talk to the ground, but it just much better integration with the system as a whole, and not having bring us to the next generation of interruptibility with interfacing with other stuff.
And also co-computer, like if you want to send high rate IMU data to co-computer for whatever image processing they are doing, even for that, it's a quite useful tool, like to be able to say, high like IMU, like AHRS data or raw IMU data to fuse directly into your vision estimation. It can be a really helpful thing as well. So, just those VDS ROS, of
and
course.
Yes, and DDS ROS. Yeah. So you'll have direct interaction with ROS. Make your driver within the autopilot. Don't have to do Mavlink conversions and none of that stuff. So that's really good. And then especially with the scripting capability, you can just interface to do whatever driver you want for whatever device is out there. So
yeah.
Thank you.
Yep. So ping, I have that down here. So yeah, so it's connected right now. So I have a static IP on my computer, and the cube red has a static IP on it. And so when I ping it, this is the rate. So one-ish milliseconds, 1.25 or so. And this is just out of the box straight. We're not modifying anything. It's just we kind of enable the feature for the IP stack to say respond to pings. One thing I want to add to this is actually do a not just a ping server, but have the aircraft have a ping client. So you could turn it on and say, I'm pinging something. How long does it take for me to ping it? But so it should be the equivalent, but it'd be nice to switch roles there. So that's a bandwidth. Mavlink. So we have Mavlink, we have Mission Planner. So as you can see, we're connected via UDP on here, and I'm just on port 13.14.4 right now. But you can see the HUD. There's no GPS on this, so it's not going to show anything interesting on there. But as I move it around here, we're connected. It's nice and fast and all that kind of stuff. And then also when you boot up, it will show you what your gateway, your IP is, and that sort of stuff. So there's some information. And so when you connect with DHCP, it would also just populate that and say, oh, I just got a new IP, and here's the IP. So you should see that right there. Yeah, so that's that one. And then what else was there? It was the throughput test. Yeah, let's do that. Oops. So
First.
go to your website, HTTP?
Yeah, I think so.
Okay. So here, I'll just click on this and take me to there. So that just takes me. Oh, that's IP in wrong on this?
It went to Google.
No, I don't want Google to do it. It's not going to know this IP. Is it going? Yeah, it's going. It's refreshing here. It's been on for a little while since the start of the. So here is our kind of just a default page that kind of threw together. But the idea is it's got some logos in it that are actually stored in the flash memory. So there's zero access to internet on this right now. It's fetching all
The
this.
server running on the
So-
column.
So this is the web server, and you can set the port to whatever, but right now it's 80. But the idea is to get some examples here of you see your IP or set it and then change some settings and whatnot. So we'll make this a little more fully featured to kind of give a good example of how to interact with parameters and that sort of thing. But just showing that's right here, just showing CPU time, but we could be showing GPS time or whatever.
And the server is written in Lua, of course. So it's running on Lua. So
Yeah.
it's not actually taking off time of the actual processing, it's taking off time of Lua. So it is running on Lua. It's
Yeah.
not, yeah.
Yeah, all the content here is Lua.
Is Lua. It's all a Lua socket library basically we
Yeah.
have included. Yeah.
And then, so yeah, so the idea is you can click buttons here. But we also have this thing, Mission Planner Express. So we thought it'd be nice to actually try to port Mission Planner over to HTML. So we thought, let's do that. So now on the aircraft, we have a full-fledged GCS that you do everything right on there. Oh, I'm sorry, this is our image. Sorry. Just kidding. Yeah, so it's just a PNG. But the idea is this is what's it, 2 megabytes or something PNG?
Yeah.
Megabyte. But that's it loading the whole image, you know, so we can just refresh this, and it's pulling down this 2 megabyte high res image off the SD card.
Not SD. Oh, yes, SD card.
Yeah, this one's SD card. Yeah, but we can do it in embedded flash, SDs, whatever. It's just whatever. So it's pretty quick to pull up a few megs of data, right? Or that's about a megabyte per second or so. But yep, so that's and then. Where did the presentation go? Oh, it's up here. Another one? Yeah, throughput. Yeah, let's do a quick throughput demo. Let me minimize this. And right here, I'm looking at my Ethernet. So it's getting, if you can see there, it's about 80 kilobits per second on the wire for my Ethernet 2, which is what we got here. And if I'm hitting reset on this, I'm clearing this. I'm getting about 7K of bytes per second. So that times 8 plus some overhead is what the 80 kilobits is, right? So now if I go over to the configuration and I look at like net underscore, these would be the parameters we have for net, but then I have a net 1. So on here, I have net1 type 1, which is the throughput test. So I'll just turn it on. And the content is -1 right now, which means give me the hello world, whatever string, and then the duration. And so it'll actually do a throughput test with duration and then shut itself off. That way you're not just spamming yourself forever and mess up. And you can set an arbitrary what kind of size of packet you want. So you can say, well, if I'm only sending 10 bytes at a time, what's my throughput and so on. And then you dedicate. So I'm just doing a broadcast right now at 10,001 port. And when I say do it for 30 seconds, I hit right. And then over here, the throughput just kind of, so I was actually working on this before, because this bandwidth just saturated, it starts having mavlink come back and forth, so I get the ACK back on this one, but then it gets it, right? Anyways, so now we're actually up here pushing 86 megabits per second. And if I go over here, it's dumping out what it's getting as peaks and averages, and it'll run this for 30 seconds. And then it dumps out a summary. And so we're getting peak of 87. We're right in it just below that, 86 something, and yeah, total amount of bytes written. So that was 315 megabytes, right? That's actually what just went through it. So the capability is there to just do tons of data. We just need to connect some dots through the libraries to increase the bandwidth on that, or the throughput. And then I think that's all I got. So that's it. Yeah. Question, Randy.
So, what's the interface like from a programmer's point of view? Are you still going from serial manager and getting serial A, or how does it look like from a program?
So basically, there are two ways we are taking this. So one is basically if you want to integrate the app directly into Azure Pilot, so it's behind the AP networking basically module. But generally, like common users will be like if you are developing, serial or you just want to send some data, you'll mostly be using just hal.serial, and in the bracket you will from number 10 to whatever, considering that serial extensions are properly configured, is what you'll be using for your purposes. And if of course if you are doing HTTP or you're doing custom servers or custom clients, you'll be using Lua to basically set that up as well. So there's different ways, but the initial first wave would be this. I would try to get the serial extensions plus UDP over serial question, and then we'll, in the future, look at adding Lua support as well in the master. So
yeah. So right here on this one, we have the serial extension enable turned on. So that gives us the serial A type parameters. So we have protocol 2, which is for IP. And so we're saying send your data to broadcast, and it is, I'm sorry, serial protocol 2 means Mavlink. So it means Mavlink 2, just like the serial protocol.
Yeah.
Traditionally, it always says that. So we could, if it was like, was a 5, not 5, it's a
5
9,
GPS.
yeah, 5 for GPS and stuff. It's just the same thing, right? So 2 means we're gonna just be expecting Mavlinks to this, and then we say what port we're gonna talk to and IP, and then the PHY type is 1, meaning IP. 0 it assumes serial, but 1 is IP, and 2 will be drone CAN. So you could just say Mavlink at the drone CAN port or something. And then when you change this PHY, that also changes these up to be different parameters. So the idea is now with these, we have the ability to have a virtual serial port and then talk whatever protocol we want. So that's what we're doing right now to without any serial hooked up, essentially a device with no serials, you could have a virtual serial port talking Mavlink or anything else, talking to Mission Planner. So if you notice here, I'm actually talking on this port 13.13.4. That's what this is. So just a matter of, and then you can do another one. You can say, I want to send another stream. I want to do serial B and do Mavlink 2 to some other port. And so you're going to start doing multiple destinations. And
there's of course ability to do custom servers on Lua as well in the future, not now. So you don't even have to set that. You can just write scripts and do, your custom servers to do, I don't know, IP cameras and stuff like that as well. Yeah.
Yep.
I guess.
What hardware does it work on?
So right now there's, since I was working so close with QPilot, they've been really great. That's the Cube Red is, maybe you should talk about this.
Yeah, I mean,
This is your bit.
Okay. Yeah. So currently, so the first instance, of course, was done on the dev kit. Like we had the S757 dev kit, and just basically get our things what is actually required to make this possible, right? And after we did the testing on the S75 eval kit, which was the first example, then we moved on to actual hardware, which is Cube Red in front of you, which has all the things you actually need to pull this off, like extra flash and external flash and Ethernet actual physical modules that you are required to communicate. So right now we have Cube Red as a implementation, but as things go with Azure Pilot, I see it being implemented in more vital platforms probably in the future. But yeah, Cube Red is the current supported hardware for this. Yeah.
Does it work on dev kit as well? Still?
Yeah, I think so. We have a 757 example eval kit, I guess.
So who would apply with it?
Yeah. Just. I think there was.
Yeah, I just had extensions to that. So do you see it coming to Cube Orange, maybe even Cube Black one day? Is there any platforms you've been able to say, rule it out, it won't?
Cube Orange, maybe through some AP Parif modules that we are actually planning on doing a Parif module as well, which will be able to convert. I mean, Philip is showing it off like some small tiny bit that you can potentially attach over CAN, which will be able to, throughput would be just what CAN can support.
Sure.
But, if you want to do some low bandwidth data just over IP, you can potentially do that. But yeah, because of the hardware, there was no target or goal for that to be like that. Like Ethernet is something that we have started working over the last last year end stuff as well.
Okay, and then the second part of that is, this might be ambitious, but when do you think your PR master might be, you might expect to support like majors? I know it's
Yeah, I mean,
crystal ball.
it's this PR that we are showing off is actually based on top of what was merged in, because it was pending like the Chibios update that we recently did in Arju pilot. It needed that change to be able to actually add Ethernet support, right? So that has went in, and this current work is based on top of that. So it will require some cleanup. I am estimating at least 1 month to get in at least until the serial extension. So you will be able to connect at least serial ports over UDP sockets through the HAL.serial interface, basically. So that's my sort of estimate. But yeah, we'll see. Yeah.
So management of CPU usage. So I'd be curious, like during that bandwidth test where you're pushing more than 80 megabit,
Yeah.
what happens to the scheduling of other tasks? If you turned on, for example, shed debug,
Right.
do you see any task slippage?
I don't think it would be really good right now because we haven't looked through the priorities. This is something that we put together over the last week. So there's a lot of that kind of tests we still need to run. I had just normal sitting, doing Moblink. I did that test. It was still at 757 was sitting 56% idle. So it's decent, but I think we can improve that a bit as well with our proper priority management and, the throughput test, I think we still need to do. But with normal Moblink streaming, it was sitting 56% idle. On S7.
Users on.
The last one? Yeah, so Chris just asked the question, like what is the sort of CPU performance we are getting if we run things like throughput tests and, stuff like that. So yeah, that was the question. And yeah, previous.
Related to that, protection against incoming packet floods affecting the stability of the flight control.
Right. So Ethernet actually has its sort of RAM, allocated RAM. So we actually give its own sort of RAM block, SRAM3, which is 32 kilobyte long. And it is, it uses DMA to just grab data from that particular RAM section. And it also puts the data in that particular RAM section as well. So it is supposed to just stay in that region. That is how the architecture of Ethernet is done physically. So you set the memory address, you want the data packets to come in. And so we just allocate that bit of RAM, and that bit of RAM is not used for anything else, just Ethernet. So 32K of that SRAM3 is just used for Ethernet. So it shouldn't happen from, the coming in or coming out. Where we need to analyze is the LWIP stack itself is not, consuming RAM where it's not supposed to. So my guess is we'll have to define a memory pool that it can use and have restricted checks around that so that it doesn't go outside of that. So that sort of safety we need to build into the LWIP stack rather than the lower thread, which is in the lower sort of HAL level, it's already built in. Yeah. Yeah.
I saw that looks like unicast is broadcast is supported. They also support multicast.
LWIP, I think it's it's a part of LWIP stack. So whatever features are in LWIP stacks should be supported multicast, unicast.
Yes.
Yeah.
Cool, thanks.
Yeah.
And the other question is, if a user has the choice between using serial or Ethernet for the same application, recommend using Ethernet?
Depends on the application. I mean, if you really require that level of bandwidth, and also the other side is also talking IP, maybe it's a good idea, but again, it depends on application to application. Ethernet, I would say like Ethernet is here to replace anything. It's just another, application that we can have in Arju pilot. Yeah.
Yeah, for the DES stuff, we support multiple interfaces, and I think
Right.
we're gonna maybe need to come up with some recommendations for you.
Right.
Which
Yeah.
interfaces preferred.
Yeah.
Maybe we'll have to do some.
We'll have to do some work on that. Yeah.
Does LWIP support any traffic shaping, QoS kind of stuff?
Sorry, QoS. Well,
The question is does LWIP support quality of service essentially, right?
Yeah.
Not that I know of. Those are all things that that can be added to it. The intent of LWIP is to just kind of for the IoT world where it's just kind of gives you the thing with least amount of resources. So I think there'll be a lot of things that we'll be adding to it, such as that and proper FTP and other and stuff like that.
Okay. Yeah. Sorry. So LWIP library is in GPIOS. So LWIP is actually, so the question is LWIP part of GPIOS. So the answer to that question is no. LWIP has been around, I think, before even GPIOS. So it's its own basically library, open source implementation. What GPIOS has is nice little bindings that were implemented right into the GPIOS to be able to use LWIP. So yeah.
But I think to answer your question more directly is the code for LWIP is in the modules GPIOS folder. So it lives in GPIOS repo.
Okay.
It's much like we did the FAT file system. So the FAT file system isn't actually part of GPIOS, but it's an add-on that is tightly integrated with GPIOS. And LWIP is in the same fashion.
So, the STM32 boards have never had a camera interface before, and by adding Ethernet, you basically give them the ability to talk to a camera or even videos, get a video stream. I mean, that's not going to work though, right? I mean, we're not going to have the CPU on the STM32 boards to do any kind of meaningful image processing or anything like that, right?
So the question is there enough processing power basically to be able to handle video stream, right? Over IP.
Pictures, you know,
I would say the answer to that question is no, at least for now. Maybe forwarding we can do it, but I would say like, why would you do that rather than just connecting directly to wherever you are forwarding to? So I would say handling, yeah, but you can control it. So I have actually run an example where I was using the GSWAP, whatever mess that is, to actually control an IP camera using RGPilot running on STM32. So sort of I ran the antenna tracker to be able to just control the camera in, wherever direction you want to point it to. So that sort of worked. So I was able to achieve that goal to be able to control our IP cameras angles and stuff and focus or whatever. So you should be able to at least do the settings of the camera.
And sorry, the reason that it would be really amazing if you could do that is that it means that the RGPilot developers within the RGPilot development environment and, we could do more stuff, like maybe we could merge optical flow or something like that straight into RGPilot. I'm not saying, I wasn't expecting you to say yes.
So as far as handling data that has video, images, whatever, and then doing processing on them, the processing power, I think it is capable of doing that because you can kind of do it at whatever, as long as you're not trying to do it in real time. The issue is we just don't have any RAM to do any of that. Like even doing like real time JPEG decoding and encoding is going to be really hard to do that with a 1 meg type memory footprint, right? This is not the target to do your processing. However, I do think there's probably a future that we could do some things where a picture or a camera has internal storage, has a terabyte of whatever flash or SD, and then it's taking pictures and storing them, and then somehow we could sneak in there and maybe change the metadata on them, and do things like that. I think that'd be a potentially possible thing we can do. It just depends on how much processing of the JPEG we need to do, and how fast it's being generated and that kind of stuff. So it's one of those things where that's just, it's all on your wrist at that point of just making a Lua app or whatever to talk to a file system on some other drive. And
I guess to balance off of Randy's comment, maybe a good intermediary would be something like a Jetson Xavier, so have Ethernet to Xavier and then have the camera to Xavier.
Yeah. The question is adding extra GPU or whatnot. Yeah. So if you're wanting to process video and stuff, you'd want to just have something with gigs of RAM and GPU Jetsons and whatnot. But at this point, the autopilot can be anywhere on the aircraft, and it can just be plugged in with Ethernet, and it can be just done anywhere, right? So.
Yeah.
On that one, I really think directly via Ethernet, for example, with a switch in between it, you've got the Ethernet camera in there. The setting will video out through the link, but you might be adding some
control. All right, I'll move to the drone can update quickly.
Okay, yeah, well, so, yeah, Sid and I will be around all weekend, of course, you can come. I'm sure there's gonna be lots more questions.
Yeah.
But there is this other thing we wanted to try and squeeze in, and it's called another presentation.
Yeah. So just a quick drone can update. So over the last year, what has happened, sort of, I'll do a quick intro. Basically we have 4 modules that we are actively working on. So DSDL, PyDroneCan, GUI tool, the DSDLC, which allows you to generate DroneCan DSDL messages into a C code, which you can use. And of course, libcanart, which we use as a decoder and encoder of our messages and putting them on the CAN bus, right? So I'll just give you a brief about each of them and what has been going on over the last year. So we have added few messages in DSDL over the last year, like there's serial over CAN message sets that has been added. We have Open Drone ID over CAN support now. And there are a few more actuator support, new actuator message sets that have appeared. We'd like to have, like most of the manufacturers to use the existing actuator message sets, but I know there are some limitations and we sort of need to fix that. Hopefully we'll have features like extensions in the, so we can basically improve our current message quality. But yeah, prefer to use existing actuator messages rather than, coming up with a new message set or whatever. So it's good for, the ecosystem and also for the maintenance of the UAV CAN drivers. Of course, there's an addition of battery monitoring message as well now. So we have a big, battery monitoring message where people can, manufacturers can use and send, smart battery data over DroneCan now. So that's good. So this is, we actually talked about it before in networking talk. So the serial extensions, where you can basically select what type of physical layer you want to communicate your serial over. And it sort of gives you that opportunity for DroneCan as well. So this is still work in progress, and you will have ability to send serial packets over DroneCan and be able to use the HAL.serial API to do so. Yeah. Few improvements to PyDroneCan and GUI tool as well. So we have fixed all the Python, the Python version issues that we had. So we had build fails and all sorts of weird stuff happening with the newer Python versions. So that all has been fixed. And we have added support for CAN-FT in Socket CAN, which allows you to sort of do testings in Linux systems with RGPilot running on CITL. So previously we only had support for normal CAN packets, the 8-byte packets, but now we can do it for CAN-FT packets as well while using GUI tool to analyze that while it's doing that. And of course, there's a support added for marbling to signing in GUI tool so that you can basically connect to a signed marbling and be able to securely access remote CAN device, remote vehicles with CAN devices as well. So few improvements to DroneCan DSDLC as well. We have fixed some bugs in DroneCan DSDLC. So it's nothing that impacts existing message sets. So all the existing message sets are actually not using these sort of combinations. So we don't have those issues existing in our message sets, but in the future we might. So that's why we have fixed these 2 issues that we had. And we have also added support for generating wrappers around the encoders and decoders, which are C++, which allows us to do some fancy stuff that I'll do a brief discussion about that later in the slides as well. There's few improvements to libcanart as well. So we have added support for, setting what the deadline for the transmit is going to be, which we had in the libuav CAN, the, C++, like the C++ implementation of DroneCan. So we have added that support for libcanart so that we can replace that whole, heavyweight implementation of DroneCan. And we have also removed the old deprecated TSDL generator, which was actually generating broken encoders and decoders. You're not supposed to use the inbuilt generator that that was there in libcanard because it has not been maintained for a while. So if you are using that, please avoid using that and use the DroneCAN DSTLC generator. And we have removed it entirely from the libcanard, so no one actually mistakenly uses it. And also we have added support for redundant CAN/FT, CAN/CAN/FT sort of interfaces. So libcanard initially was only able to handle, one CAN port at a time. It has no idea of having like multiple interfaces sort of as a backup, but now it has that feature. So basically these three things make it feature complete as far as replacing libuav CAN is concerned, and which is the next step we do, is to actually remove libuav CAN from ArduPilot because of its heavyweight and complex nature, and replace it with a nice C++ wrapper around libcanard, right? So this is what I have been working on for the canard, right? So we have this C++ wrapper around libcanard, which has, basically it is physical layer agnostic, which means you can, right now it's doing CAN and CAN/FT. In the future, it will allow us to add different interfaces, right? Like it can be, I don't know, serial, Ethernet, or any other, shared memory like interfaces that you want to have instead of CAN. So this makes it nice and easy to do that because it just abstracts out the interface layer in front of canard. And I've tried to reduce the use of templates so that we are not just adding unnecessary flash costs just for the right of, simplification and abstraction. So I have done this in a way that I literally looked at what is, the cost on flash and RAM is going to be with each of the, template addition that I've done in the code. So it's been written in a way that it is lightweight, but it still is powerful enough for people to use in, a simplified way. Of course, it's lightweight, and it basically gives us 65 kilobytes of memory of flash back in ArduPilot that we can reclaim and use it for other fun stuff. Ethernet, yeah. So yeah, I mean that flash space is going to be key because we are actually getting close to flash running out of flash even on 2M boards. So this saving is going to be very, very useful for ArduPilot. And of course, a simple loopback test like there has been missing in libuav CAN implementation in ArduPilot to be able to just use CITL to test its own sort of UAV CAN drivers. So that is a simple feature that should have been had from the day dot, has been added, and we can now self-test all the UAV CAN drivers in CITL without needing any external sort of requirement of socket CAN or all that stuff. So that is a nice thing that has been added as well. So size compare, as you can see, 65K of flash saved in our source of vehicle, except for Blimp, which probably doesn't use much of UAV CAN drivers. So this is sort of a comparison of what we were doing before and after. So as you can see on the left, the red is the before code. I'm not sure if it is quite visible, but as you can see, it's like a complex sort of template structure that people had to write, and it, sort of repeating their own sort of message, and it's just room for error in that is actually quite great. So this sort of makes it concise, and just a single line can easily make you subscribe to a message. So you just write allocates about callback, and it will just infer the message type you want to handle from the function itself, and it will create all the boilerplate for you without much cost in flash. I have forgotten the numbers, but it's very, very tiny, and that's why we are getting the flash gain that we got. And basically just do all the boilerplate for you, as compared to what we do in AP_parif, which is just, you have to write at least 3 different functions, edit 3 different functions to be able to handle a message, right? Whereas this gives you a nice and compact API to do so. So this is basically a new way to subscribe messages in ArduPilot world. Hopefully we can bring that to AP_parif. I'm not sure, but I would like to. This is a list of upcoming work in DroneCAN. So I want to finish serial over DroneCAN. I want to add node capabilities in ArduPilot and all the DroneCAN world. So hopefully it is part of the wrappers, the libcan art, so that other basically users of DroneCAN can also use it off the shelf. We want to add message extensions, so be able to add messages, add fields into the messages, which is not present. Basically, if you want to have a new sort of field in a GPS message, you want GPS time in weeks or something like that. It's just not possible. You have to just come up with entirely new message sets, which is sort of painful. So we will try to change that and make it easy to do so. So that's something that we want to work on, and I want to basically create applications in libcan or C++ wrappers as well, so that the DroneCAN users basically be able to use features like dynamic node allocation, time sync, parameter management, and all that stuff right off the shelf, rather than every time implementing their own. So that would be a useful thing to have. That's one of the things that libuav can sort of had going for it. But unfortunately, due to its complex nature, I don't think many consumers of DroneCAN were actually using those techniques. Even in ArduPilot, we almost always had to write our own sort of implementation for everything. So that would be good to have as well. And of course, more tests. We want to test whatever we are doing in DroneCAN space so that it is, basically, always working and not breaking. And yeah, probably add Ethernet as a physical layer to DroneCAN. So that would be a good thing to have as well. Yeah, I think that's about it. Any questions or any more discussions? Or
This so sounds like startup DroneCAN V2.
maybe we'll call it 1.2.
It's evolved DroneCAN.
Yes.
Not
Replace DroneCAN. Compatibility, yeah. I would call it 1.2 rather than V2, because we want to do incremental changes. Maybe V2 would be some extra big feature that comes in. We'll call it V2, but incremental changes make it compatible with what we already have. And I don't think it's a good idea to play the number game anyways, like V1, V2. I mean, it's just application, what application needs you have, and we need to work towards solving those problems rather than just,
There's a precedent for Mavlink too.
Yeah. There is. Yeah, we can do that.
Encryption, you can call it anytime.
Yeah.
Basic question about what kind of nodes is the impact intended for, and who would do this?
So the question is, what kind of nodes is the DroneCAN intended for? So DroneCAN is basically a intra-vehicular communication protocol. So any basically actuator, sensor, or active system in your basically vehicle you want to talk to or exchange information with, it's for that sort of purpose. It's not meant for off-board comms. It's not meant to be used like a Mavlink, for instance. So it is for intra-vehicular communication basically, and it's supposed to be scheduling.
Actuators.
Right. So priorities, I think that's what you mean. Like, who decides what the priority of the message? And this is something like right now, I think it's very ad hoc. Like every sort of manufacturer sort of defines their own, priority for the particular message sets. There's of course the message ID as well that sort of governs what the priority is going to be. But generally, it's up to the manufacturer to decide what the priority of the message is going to be. Is sort of bad. I think it would be a good idea to have sort of that as a, parameter or configuration in the future for users to be able to choose what the priority of the message that is coming onto the bus is going to be. So that is something I do intend to discuss with, all the other DroneCAN
Question
partners.
scheduling even if I decide the priorities,
Yeah.
who does the scheduling?
It's inherent to the canvas. So if you look at the canvas protocol itself, based on the node ID, the arbitration happens at the node ID level. So it happens on the wire level. It's not done by a central a scheduler or anything. So it's baked into the CAN, and that is where CAN is a pretty good protocol, where it allows you to basically manage priorities and scheduling based on the message ID. But we should probably at least give some ability for integrators to be able to set those configurations, and that level of granularity is still not there, but hopefully we can get there eventually. Yeah. Nothing else.
So, thank you very much, Sid and Tom.